Okay, here we go, last one. So now we're going to go for number 16, which is a graphing the rational function problem. Start by factoring. So looks like the numerator is something I can group, right? First two, last two. So the first two I can take out an x squared, which leaves 3x minus 1. The last two I'm going to take out a negative 4, which leaves 3x minus 1. So that's nice. It works out to be x squared minus 4. So I'm going to go ahead and factor that as an x plus 2x minus 2. And then the 3x minus 1. Okay, numerator's factored. How about denominator? Multiplies to be 2, adds to be 3. Looks like I would use a 2 and a 1. So there's my denominator. X plus 2, what's a plus 1? X plus 1. Okay, so everything's factored. So the first thing I want to check for before I actually get to a graph are the holes. Remember, holes come from canceling terms. I notice a factor of x plus 2 on both top and bottom. So that's going to create a hole in my graph. And the value that creates the hole is wherever that equals 0. So x equals negative 2 if we're going to have a hole. Now remember, it's the first thing we find, but probably the last thing that we'll graph. Okay, I'm going to jump down to asymptotes just because that's how I normally order them. So vertical asymptotes come from the denominator. So any remaining factors, and we're just going to use what's left over here. Any remaining factors I'm going to set equal to 0 on from the denominator and see what x equals. So it looks like x equals negative 1. Remember, asymptotes, any asymptote you write as an equation. These are lines, not just points. So x equals negative 1, my vertical asymptote. Horizontal asymptote, we're going to look at the degrees of numerator denominator. The top, it has a square. The bottom has a 1, so where the top is bigger than the bottom in terms of its degree. And when that happens, there's no horizontal asymptote, but that usually does create a slant asymptote because the top degree is 1 more than the bottom. So we've got some division to do. The good news is, since the bottom just has that one linear term in it, I can use synthetic division. So I'm going to do negative 1 going into whatever is left on top. So because I'm using the simplified form, I need to know what that simplified version is on top. So I'm going to FOIL it out. So foiling it out, I've got 3x squared minus x minus 6x plus 2, or 3x squared minus 7x plus 2. So that's equivalent to what we had there on top. So that's what I'm going to do my synthetic division with. 3, negative 7, and 2. 3 comes down, multiply to get negative 3, and add. Multiply to get 10, and add. Now remember, if you have a remainder, there's a problem, because that means you didn't cancel out something that was a factor. So that's, or if you don't have a remainder, is that what I said? If you don't have a remainder, there's a problem. I've got a remainder, I get to just ignore it. I'm left with 3 and negative 10, which represents, again, remember it's an equation, y equals 3x minus 10. So there's my slant asymptote, y equals 3x minus 10. So I've got all my asymptotes taken care of. Now we just need to figure out what my intercepts are. X-intercepts come from the numerator. For a function, or for a fraction to equal 0, it just means the numerator does. I had 2 factors left in the numerator. I had an x minus 2, and I had a 3x minus 1. So they're going to create the x-intercepts for me. So x-intercept at 2 and 1/3. And then y-intercept is what we get by putting 0 in for x. You can either go back to the original equation, you can go back to the factored one, the simplified one, wherever you need to. Honestly, I'm going to go back to the original, because when I plug in zeros for everything, the only thing that's left are the constants at the end. So the y-intercepts end up being 4 over 2, or 2. Okay, so let's start graphing. I'm going to change some colors here. Okay, so how about I've got vertical asymptote at negative 1. Scroll down a touch. There we go. Vertical asymptote at negative 1. Vertical asymptote, that's my only one. No horizontal. Slant asymptote at 3x minus 10. So start down here at negative 10. Do a slope of 3. 1, 2, 3, 1. 2, 3, 1. And graph that down there. Looks like we're going up the screen. Let's go down a little more. We have intercepts. Let's go blue. Intercepts at x equals 2, x equals 1/3. And then y-intercept at positive value of 2. You should be able to see this little section in here, this little triangle-shaped section, and be able to fill it in. And it's going to come down, go through the intercept, and right back up. So there's the section to the right of my vertical asymptote. Now I just need to see what happens on the left. My guess is, because we've all seen that symmetry, we're going to get a little parabola type guy in the other triangle shape. But I'm going to pick a point just to make sure. So let's say we choose -2 as our x value. What happens when x is -2? Again, you can plug this into any version of the function that you want. The easiest one is going to be that simplified one that we came up with, which with whichever numerator you want. So if I put in -2, I've got 3 times 4, 12, plus 14, 26 plus 2 is 28. There's our top. The bottom is just -2 plus 1, which is -1. So I get an x value of -28. It's way off the graph. That's okay. I'm just going to kind of estimate it down there. And then we're going blue. So -2 is way down here at -28. I know, not a very good estimate. It's okay. I'm going to keep these guys going. But I know it's in that section there, so I can go ahead and do my other piece of graph in that area. Now remember, the last thing we need to take care of was the first thing we found. I have a hole at -2. So if we'd plugged -2 into the original function, we would have had an issue. But because there's a hole, I'm going to erase a tiny bit of my graph. Actually, that point I plotted. And then plug in the hole instead. And there it is.